This is question number 26 of set 2 mechanical engineering paper of GATE 2019. The question is, given a vector u vector is equal to 1 by 3 negative y cube I cap plus x cube j cap plus z cube k cap and n cap as the unit normal vector to the surface of the hemisphere x square plus y square plus z square is equal to 1 where z is greater than equal to 0. The value of integral curl of u vector dot n cap into ds evaluated on the curved surface of the hemisphere S is. So among these four options we need to tell the value of this integral. Now this problem or this integral can be solved using Stokes theorem. Now before proceeding any further, let's understand what Stokes theorem is. So according to the Stokes theorem for surface integral, it says the surface integral of the curl of a function over a surface bounded by a closed surface S is equal to the line integral of a particular vector function around that surface. C here represent the closed loop. Now let's understand Stokes theorem for our problem. So in our problem, the surface given to us is a hemisphere. First let's draw the hemisphere. Let's say this is the hemisphere given in the problem, which is given by x square plus y square plus z square is equal to 1. Now if you observe here that z is always greater than or equal to 0, that means it is on the xy plane where z is equal to 0. So the hemisphere is sliced here in the xy plane. Now if you observe this plane, this is a circle. Now the bottom part of the hemisphere is a circle which lies on the xy plane, which can be represented in this diagram as like this. And the equation of this circle can be written as x square plus y square is equal to 1, because obviously it is in xy plane, its center is at the origin and its radius is equal to 1. Now if from origin, if you draw any radius, this line here, it represents dr vector here, okay, and if you try to represent it on the xy plane here, it will look something like this. So suppose this is dr, so this right here, it is dr. So dr can be expressed in terms of x and y, so this vertical and horizontal line, so this is dy and this is dx. So you can write dr vector is equal to dx I cap plus dy j cap. Now according to Stokes theorem, we need to calculate the line integral on this curved surface C. Okay, so we can write the Stokes theorem as the line integral of C u vector dot dr vector. This we can write as integral C, and the function u vector is given 1 by 3 negative 1 by 3 y cube I cap plus 1 by 3 x cube j cap plus 1 by 3 z cube k cap, and this we will dot product with dr vector, that is dx I cap plus dy j cap. And now this integral can be written as integral on closed loop C is, I'll take 1 by 3, so we will multiply I cap with I cap vector, so we will get y cube dx plus closed integral on curve C x cube dy. Since we are integrating on the closed curve C, that is the expression of this circle x square plus y square is equal to 1. So now if you take any point on this circle here, suppose this point here P, so the coordinate of this point is r cos theta, that is x is equal to r cos theta, and y is equal to r sine theta. Now for this problem r is equal to 1. So the x coordinate will be cos theta and y will be sine theta. So we can write here on the circle or closed loop C, x is equal to cos theta. So dx will be equal to minus sine theta d theta. Also y is equal to sine theta. So dy will be equal to cos theta d theta. Now you must have understood why I converted this x and y into theta, because now we'll be having only one variable to deal with, and also we can put the limit of integration easily from 0 to 2 pi. So the above integral, this integral can again be written in terms of theta. We can write it as 1 by 3 integral 0 to 2 pi sine, this is negative 1 by 3 sine cube, y is sine theta, so sine cube theta, and dx we are getting minus sine theta d theta, right? And again we can write plus integral 0 to 2 pi 1 by 3, and here we have what we have here, x cube dy. So x cube, x value is cos theta, so cos cube theta, and dy is cos theta d theta. So again we can write the above expression as, this integral can be written as 1 by 3 0 to 2 pi sine 4 theta d theta plus integral 1 by 3 we can take outside here also, 0 to 2 pi cos to the power of 4 theta d theta. So this is the value of line integral that we are getting. Now to integrate sine to the power of 4 theta and cos to the power of 4 theta, it's very difficult, as it's a very long procedure actually. So we can use, in definite integral, we can use Wallis formula. Now according to Wallis formula, an easy way to evaluate integral 0 to pi by 2 sine to the power of nx into dx is equal to integral 0 to pi by 2 cos to the power of nx into dx for all n belongs to positive integer, and this can be calculated using n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4, and this will keep going on until we reach 1 by 2, or let's say the last three terms will be 3 by 4, 1 by 2 into pi by 2. Here n is even, so n here is even. So if n is odd, we will use the formula n minus 1 by n into n minus 3 by n minus 2 till we reach the last three terms, 4 by 5 into 2 by 3 into 1, and here we won't be multiplying pi by 2. So here for this is for n is equal to odd, if n is odd integer. Here this formula is valid when n is even integer. So now here we need to calculate this line integral. Integral on closed loop C, u vector dot dr vector is equal to 1 by 3 0 to 2 pi sine to the power of 4 theta d theta plus 1 by 3 integral 0 to 2 pi cos to the power of 4 theta into d theta. Now if you see this sine to the power of 4 theta and cos to the power of 4 theta, both are even function. That means sine to the power of 4 theta is equal to sine minus theta to the power of 4, right? And same goes with cos function as well. Cos to the power of 4 theta is equal to cos of minus theta to the power of 4. See, cos of minus theta itself is cos theta, and that to the power of 4 will give cos to the power of 4 theta. So even function is when f of minus theta is equal to f of theta. Then we say the function is even function. And since this function is even, so we can convert the integral 0 to 2 pi into 4 times of 0 to pi by 2. So we can also write the above integral as contour integral c u vector dot dr vector is equal to 4 by 3 0 to pi by 2 sine to the power of 4 theta d theta plus 4 by 3 integral 0 to pi by 2 cos to the power of 4 theta d theta. Now if we apply Wallis theorem here, using Wallis rule, we can just take 4 by 3 common, and so the value of n here is 4 according to Wallis formula. N is 4, so we will write 4 minus 1, that will be 3, divided by n, that is 4, into now n minus 3, so n is 4, so this will be 1 by n minus 2, that is 2, into pi by 2 plus 3 by 4, that is n minus 1 by n, into n minus 3 by n minus 2 into pi by 2. So we can cancel out 3 from here, and 4 also can be cancelled out, because 4 by 3 is outside and 3 by 4 is multiplied in both the terms, so we can cancel these two out, and we can write it as, so pi by 4 plus pi by 4, it will give you pi by 2. So the value of this integral c u vector dot dr vector is equal to pi by 2, which is also equal to, using the Stokes theorem, closed integral on surface S del cross u vector, that is curl of u vector, dot n cap into ds on the surface ds, which is our required answer. Now let's go back to the question and match with the given options. So we see here option C is the correct choice. To get more information on Stokes theorem, you can follow the NPTEL course on integral and vector calculus by Professor Hari Shankar Mahato of the Department of Mathematics, IIT Kharagpur. Hopefully I was able to solve your doubt. Have a great day. Thank you.